This is one of the most powerful tools in modern endpoint engineering: self-healing devices. Intune proactive remediations let you ship a pair of scripts, one that finds a problem and one that fixes it, to thousands of machines on a schedule. By the end, you will write a correct detection and remediation pair and understand the exit code contract that ties them together. A proactive remediation, now just called a remediation in Intune, is a pair of PowerShell scripts that run on a schedule through the Intune management extension. The first is a detection script that decides whether a problem exists. The second is a remediation script that fixes it. The two communicate through a strict exit code contract, and getting that contract right is the whole game. Crucially, the pair model lets you measure how widespread an issue is before you change a single device. Here is the contract, and it is simple but unforgiving. From the detection script, exit code 0 means the device is healthy, so do nothing. Exit code 1 means a problem was found, so run the remediation. That is it. Get this backwards and you either never remediate or you remediate healthy machines. Use the exit keyword explicitly with the right number, and be aware of the $last exit code automatic variable when you call other tools. A good detection script is fast, read-only, and decisive. It checks a condition, writes a short human-readable status line with right-output, then exits with the right code. That status matters because the last line you write to standard output becomes the pre-remediation output shown in the Intune report. Here we check whether the Windows time service is running and set to automatic. If yes, exit 0. If not, write Y and exit 1. The remediation script must be idempotent. That word means running it again on an already fixed device must be harmless and produce the same end state. Because remediations run on a schedule, this is non-negotiable. Always wrap your changes in try-catch, exit 0 when the fix succeeds, and exit non-0 when it fails, so Intune records the failure honestly. Here we set the service to automatic and start it. Run it twice and nothing bad happens, it just reasserts the state. Two settings change how your scripts behave, and the first is context. By default, a remediation runs as the local system account, which is right for machine-wide changes like services and the HKLM Hive. But if you need to touch a per-user setting or the HKCU Hive, you must choose to run it in the logged-on user context. Picking the wrong context is a classic cause of a remediation that reports success but does not actually fix what the user sees. Match the context to the change. The second setting is bitness. By default, your script can run in 32-bit PowerShell, and on modern Windows that means registry and file system calls get quietly redirected to the WOW6432 node view. So if you read a 64-bit registry key or a 64-bit program path, set run script in 64-bit PowerShell to yes. Otherwise your detection reads the wrong view, sees the wrong state, and your whole remediation gives wrong answers. When in doubt, run 64-bit. You assign a remediation to a device or user group with a schedule, once, hourly, or daily, and Intune then reports detection and remediation status for every device. You can also manage these through Graph, where they appear as device health script resources. A pro move: deploy detection only first, a remediation that just reports and never changes anything, to size how widespread the issue really is. Then add the fix and pilot it on a small ring before going wide. Let us recap. Detection exits 0 for healthy and 1 when a fix is needed. The remediation must be idempotent, wrapped in try-catch, exiting 0 on success and non-0 on failure. Match the context, system or user, and the bitness to the change you are making. And pilot detection only first, then ring out the fix. Your task: build a complete remediation pair for a stale DNS cache or a disabled firewall profile. Detection read-only, one clear status line, correct exit code. Remediation idempotent, try-catch, exit 0 or 1. State the context and bitness it needs and why. Then use invoke-mg graph request to list the device health scripts in your tenant. See you in Lesson 5.